Hello everyone. Today I'm going to solve the differential equation that is called Cauchy-Euler equation. So the way that we can solve these types of Cauchy-Euler equation is by assuming y equal x to the m, and m is unknown variable here. But the goal is to find the right and appropriate m based on the differential equation that we have. So in the differential equation, we need to find y prime, y double prime, and then plug all the thing together to find the right m. But because y is x to the m, y prime would be m times x to the m minus 1. And also y double prime is m times m minus 1 times x to the m minus 2, as we can see. So after plugging all the y prime and y double prime in the original differential equation, which is in red, so we would have something like this line. So after putting all the stuff together and multiplying this x squared to the x to the m minus 1 minus 2, we would have x to the m here, and the same thing here. If multiply this x to the xm minus 1, we would have xm, and finally we have xm in all the terms in this equality, and then we can take out the x to the m and we will left with this red parentheses. Okay, so we have this term from the first, and this 6 to the m, 6 times m from the second one, and the 1 after taking out xm, we will left with 1 for the last one. So we have this line. So, and this multiplication is 0, so it means multiplication of this times this red parenthesis should be 0. On the other hand, we know that based on our assumption y equal xm is the non-trivial solution. Non-trivial means y should not be 0, y is not equal to 0. So that's why if this is not equal to 0 and the multiplication of these two terms is 0, definitely the second should be, the parentheses, the terms inside the parentheses should be 0. So what does it mean? It means this line should be 0, right? And after after distributing these terms to the parentheses and summing them up, we will get 3m squared plus 3m plus 1 equals 0. This is as we know, this is a quadratic equation, and in general case for quadratic equation like am squared plus bm plus c, we would have the root of this square quadratic equation as n equal minus b plus minus square root of b squared minus 4 times a times c over 2a. So we have a, we have b, and we have c. We just need to plug all the stuff together to get two different m in this case. So for our special case, which is this line, okay, so the A would be 3, B would be 3, and C would be 3. So based on this formula, we would have this M, right? And after simplifying more, we will get minus 1 half plus minus I square root of 3 over 6. So we find M, and we know that y in the top should be x to the m. But how we can get from this, minus this, this that I'm trying to show by my cursor, minus 1 half plus I square root of 3 over 6 to get the solution as a y. So we just need to put the m as a power of x, and then we will get something like this. But how we can find the second terms? For the first term, it's clear because we have a x to the minus 1 half, and we have it here, right? But how about the second one? So y x to the I square root of 3 over 6 is cosine of square root of 3 over 6 times natural log of x. So we can describe it here. So in the right hand side and in the bottom. So x to the I square root of 3 over 6 is equal to e to the natural log of that terms, which is x to the I square root of 3 over 6. And based on the property of natural log, this as a power of x can be moved next to the natural log, when we would have I square root of 3 over 6 times natural log of x. So, and finally we would have e to these terms, and e to the I something like this would be cosine of that statement plus sine of this statement. So that's why we would have the final solution of y as the last line, and we are done. Thank you. Please subscribe the channel and hit the like button. Thank you. And if you have any types of integral or differential equation, please put it in the chat, and I will solve this, and I will reply your